IQ2 just announced a radical shift from a pedal adapter with a whole lot of flaws and problems and an existing product that is identical in almost every way, failing in the marketplace, to a pedal with less flaws, but they're carrying over a lot of their bad ideology here. So hopefully, if I can talk about it, maybe people will let them know, maybe they'll see it, and then they can fix it, because they're a hair away from having an actual good design, but they have to put more money into production in order to do it. And I don't think that price point that they have is achievable unless they have some sort of miracle strain gauge installation technology. And based on what I've been able to dig up about the company and patents, they don't. So before we get to this, let's talk a little bit about some of those failings that have happened, because there has been a lot of failed power meters. In fact, there are a bunch that I can't even find remnants of on the internet anymore. IQ2 moving away from this design, and they said it was related to inconsistency or some variation of that language. And why is there inconsistency in this design? Well, the first obvious flaw of this is actually a very simple one, but it's that it requires this jam nut. When you tighten it, you're not actually tightening on the threads, you're tightening against some sort of a jam nut. And early Look Polar solution, which is now the Look SRM, the strain gauges and the mechanics are actually identical. You have to orient them, and then you usually use a jam nut. But that orientation has to be very precise. In one direction, it's the sine of 0 degrees, and in the other, it's this cosine. So it's being +1 with one of the trig functions or the other one actually is quite different. So right now we've got that flaw, and they've kind of ditched anything happening on the other side. So they've got one strain gauge installation, presumably to reduce cost, but that also has a bunch of other issues. They're using essentially an axial design. You're not expecting a lot of axial force here, but if you misalign it, you're going to get a lot more than you expect. So, orientation, messing things up. Messes it up doubly when you use a single-sided strain gauge setup, which is kind of the poor man's method of trying to make things work. Watt team tried this, and we saw what that got them. But the jam nut is especially problematic in this vicinity, and it's also problematic on any Shimano-based power meter that uses pinch bolts, if you take that power meter and then install it, cinch it up and zero it and then write it, your data is always wrong. It always has an offset. Because when you put it on, the splines were kind of loose, and then when you pedaled, it shifted. And then it caused, I use the term captured strain. I don't really have an official term for this, but I use captured strain. And in order to explain what captured strain is, let's take a regular beam example, but let's put it vertically. So when we do that, let's push horizontally, and let's say that these beams are equivalent and massless and all sorts of magical things we do in physics and engineering, less in engineering, but we apply 1,000 newtons of force, essentially, a 100 kilo sack of potatoes, we get a deflection of 1 millimeter. We do the same over here. But what if we have two hooks that are each half a meter apart, and every now and then you get the potato salesman and he comes along and he's like, I'm going to put my potatoes on this side of the beam. And because it's 0.5 meters, the force is say 1,000 newtons, the amount of torque it causes then is 500 newton meters, whereas this, the torque would be 1,000 newton meters. So it actually causes a similar lateral deflection because you're twisting it. And that lateral deflection is plus or minus half a millimeter. So if someone comes along randomly, they don't, and laying a sack of potatoes on either side, it's affecting how much it moves, but it doesn't really affect the response. It doesn't affect the slope of a power meter, but it affects the offset. And that means, you just got a zero offset. Unless it can slip around. So with the splines on a Shimano style crank, they generally on that upstroke, they don't relax enough that they make a difference. So you just got to kind of get them seated, seat them hard, and they kind of stay put. But if you do things like stretching on it and you balance the other way, you reverse that seating from one side to the other, and then it can cause the different offset. So that's what's happening here is with the jam nut and all the huge amount of forces at this kind of knuckle area, you get it sliding. So on the downstroke, it'll slide down. And then it's like someone came and put a sack of potatoes on one side. So you get an offset. And your strain gauge gets an offset. And then it's wrong. Okay, you stop and you re-zero. And then on the upstroke, it shifted back. Okay, are you going to stop every half a stroke and re-zero your power meter? And it's not even predictable. It's a Coulomb friction slidiness weird mess. All right, so we've got the orientation problem. We've got the Coulomb friction problem. Let's get rid of them. Move that strain gauge out to a pedal. Jam nut, yeah, we'll leave it for cost saving measures, but frankly, no one should be buying pedals that can't figure out their orientation now. It's just one of those, the benefit of the pedal is that it's easier to install and travel with. Well, not if you have to get a bunch of stupid alignment tools. Moving to that pedal, we eliminated a lot of this Coulomb friction problems. It's still there because they've got a one-axis sensor, kind of like the antique B Pros and the Look Polar and the new Look SRM pedal, which is mechanically and strain gauge way is the Look Polar. It is not different. Electronics are different, but the strain gauge and stuff is not. So they got rid of that here, but there's something very concerning about this design that they show in pictures. It looks like the pedal is centered over that sensing area. Well, that's not really good. The reason it's not good is because they'll have to have bearings on either side. And if we go back to our classic beam example, if I put a force out here, I get this nice blue line. The moment is constant. If I put a strain gauge here versus here, it follows that moment. But if I put a force out here, then if I have a strain gauge in here, I can't see that. So if I have a bearing out here and one out here, if I pedal pushing doubly hard here as here, and I assume that it's supposed to be equal, so therefore I'm doubling the reading, I'm not going to get a very accurate number. It's actually going to give me double the power. Same with if I have all my force on the inside bearing and my sensors out here, I get 0. I'm going to potentially have a power meter if I'm like very narrow hipped inside, pedal offset in, of 0 power. How do you design a power meter with 0 power? So they could totally, let us hope that they are just artistic renderings. They're not scale accurate. Got to move this in, guys. You got to move it back. Not too close. Not too close. Just, just right. It's the too hot, too cold scenario. We're looking for the Goldilocks locations back here. This arrangement is super weak. It is mechanically designed to make things super, super weak. The upside is this is how every kitchen weight scale that costs $10 at like Target works. They have one single gauge at the top that's usually contraflecture. I think their picture actually shows more of a weird Poisson contraflecture setup, which I would avoid. But I don't like this. It makes it mechanically weak, but it's also laterally weak. You took a lot of material out of that area, and it's now much more flexy. And that's not too good. In fact, pedals are kind of near their limits for fatigue strength. Like, they do realize that in order to legally sell this, they have to do 100,000 cycles at 1,800 newtons. That's like twice my weight on one pedal, pushing it down 100,000 times. I don't think that'll pass. And if they sell that and that fails and they don't have their ISO or previously CEN test completed, there's going to be lawsuits. They'd be better off just mill those sections flat, keep that strain. The flat, not so great for stress risers on the corners. Keep those flat though. Put a second strain gauge on the bottom, or do what Look has been doing, or Polar, or SRM now. Just use the shear gauge setup. I don't like the shear gauge setup compared to what Garmin and Asioma does with what's called a differential bending beam, but because of the bearings, it constrains enough that it works. Realistically, the differential bending beam is better, but requires either more inputs, better calibration, better gauge placement, and all these things. So I'd mill these flat, throw the gauge on the top and the bottom, stick with the jam nut if you don't mind having a terrible user experience, but you do save a chunk of the cost.